In this video, we will discuss logical operators and how to use them to evaluate compound relational statements in Java. In an earlier video, we discussed relational operators and said they are used to evaluate the relationship between two values. However, consider the following relation, which checks if x is greater than 5 and less than or equal to 10. Can we input this to Java? Let's give it a try. Here I will define x to be an int and assign the value 7 to it. Then I try to enter the expression as it is. When I compile, Java gives me an error. The error indicates that we are using bad operands for the binary operator. The relational operator expects types that match to check them, but it complains that one is Boolean and the other is an int. The Boolean comes from the first part of the expression, which Java evaluates. It results in true because x is greater than 7, but then we are trying to ask Java if true is less than an int, which is 10. Alright, so what's the right way to do that? Let's think of how do we read this expression in a high-level language. We say x is greater than 5 and x is less than or equal to 10. We know how to express both of these expressions except for the AND part. So how do we tell Java AND? Well, Java has a way to do that. In fact, Java provides 3 operators referred to as the logical operators. One of them is AND, the other is OR, and the third is a logical operator called the logical NOT. The AND operator is obtained by clicking the shift and number 7 on your keyboard. It connects two Boolean expressions, which means it operates on true and false values. Since it's an AND, it means that the first expression and the second expression must be true for it to be true. The second operator is OR. You can obtain it from the shift and backslash on your keyboard. Similar to the AND operator, the OR operator connects two expressions. The first or the second expression need to be true for the whole expression to be true. The last operator is unary and operates on a single Boolean expression. If the expression is true, the NOT operator makes it false, and if the expression is false, the NOT operator will make it true. This means it reverses the expression. To visualize how AND and OR logical operator work, consider this. A person wants to cross from one side to another through logical expression operated bridges. If the expression is false, the bridge is open and the person can't cross. On the other hand, if the expression is right, the bridge is closed and the person can cross. There are two expressions for the two bridges. The way the bridges are set in this case is like the logical AND operator. If both expressions are false, both bridges are open and the person can't pass. If one is false and the other is true, this is still not good. Even if you reverse the true and the false, our friend still can't cross to the other side. With AND logical operator, the person can pass if and only if both expressions are true. Alright, what about the OR? The OR is represented using the following setup of the bridges. If both expressions are false, the whole expression is false and the person can't cross to the other side. However, if one of the expressions is true, the person can cross to the other side and the whole expression becomes true. In fact, it doesn't matter which one of them is true. If both are true, you can imagine that the person can cross using any of them, and in this case, the whole expression is true. Alright, so let's check some examples in BlueJ. I start by initializing two integer variables, x and y. I start by checking if x is equal to 5 and greater than 1. Both of the expressions are true. X is actually equal to 5 and greater than 1, and that's why Java will give true. Now let's check if x is greater than 1 and x is greater than 12, which is false. Now what about x is less than 1 and y is equal to 10? Even though y is equal to 10, which is true, x is less than 1 is false, and false and true is equal to false. Let's try with the or. Let's check if x is less than 1 or y is greater than 200. Both of them are false, and this results in false or false, which gives you false. Now let's check if y is greater than 100, but x is greater than 1, which is true. So now we have true or false, which is true. What about x is equal to 5 or y is equal to 10? Both expressions are true, which means we have true or true, which is true. Now I try to reverse this using the not operator, which will turn this into true. You can also work with Boolean variables. Here I declare the isEmpty variable, which is set to true. Then I say not isEmpty, which is going to be not true, which is false. Putting it all together, the logical not operator has the highest precedence, followed by the multiplication, division, modulus, addition, and subtraction. Then comes the relational operators. The logical and or come after the relational operators, with the and having higher precedence than the or.